Good morning. Today we are going to discuss about Afbau principle. Afbau is a German word which means filling up. According to Afbau principle, the electron enters into lower energy orbit. After filling the lower energy orbital, then it enters into the next higher energy orbital. Like that the sequence will go on. Let me show you the sequence. This value, filling of this orbital is based on n plus L value. Let us calculate for 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d and 6f. Let us calculate n plus L value. So, electron always enters into the orbital which has a minimum n plus L value. Which has the lowest n plus L value, the electron will enter. Coming to 1s, it is n value is 1, L value is 0. So it is 1, 2s, 2 plus 0. See, L value for s orbital will be 0, L value for p orbital will be 1, L value for d orbital will be 2, L value for f orbital will be 3. 2 plus 0, 2, 2 plus 1, 3, 3 plus 0, 3, 3 plus 1, 4, 3 plus 2, 5, 4 plus 0, 4, 4 plus 1, 5, 4 plus 2, 6, 4 plus 3, 7, 5 plus 0, 5, 5 plus 1, 6, 5 plus 2, 7, 5 plus 3, 8, 6 plus 0, 6, 6 plus 1, 7, 6 plus 2, 8, 6 plus 3, 9. So, these are the values of n plus L. Everybody know that n is a principal quantum number, L is a azimuthal quantum number or angular momentum quantum number. Principal quantum number was discovered by Niels Bohr. Azimuthal quantum number was discovered by Arnold Sommerfeld. N gives idea about number of shells and L gives idea about number of subshells. Now you see here 1s. First the electron will goes into 1s. Next the electron will goes into 2s. Then 2p. Then 3s. Then 3p. After going into 3p, electron will not go into 3d because 4s is minimum than 3d. 4s orbital has lowest value when compared to 3d. That is the reason why it goes into 4s. After going into 4s, it goes into 3d. After going into 3d, it goes into 4p. After going into 4p, it goes into 5s. After going into 5s, it goes into 4d. After going into 4d, it again goes into 5p. And after going into 5p, it goes into 4f. After going into 4f, it again goes into, before going into 4f, it goes into 6s. After going into 6s, it goes into 4f. And the series continues. So, what Afbau principle says, Afbau is nothing but building up. The electron first fills the lower energy orbital, after that next lower energy orbital, after that next it continues. So, the electron always goes into lower energy orbital. It building up the energy. This principle is called Afbau principle. And in this class only, we are going to study about Hunds rule. Hunds rule says that the pairing of electron takes place after filling all the available degenerate orbitals. Hunds rule says that the pairing of electron takes place after filling all the degenerate orbitals. What do you mean by degenerate orbitals? Degenerate orbitals means orbitals having same energy levels. Let me show you some examples to explain about Hund's rule. Before explaining about Hund's rule, I would like to say you the definition. The pairing of electron takes place after filling all the available degenerate orbitals. Let me take the example of carbon. Carbon atomic number is 6. Atomic number is nothing but the number of electrons or number of protons present in an atom is nothing but atomic number. Atomic number is denoted by Z. Basing on atomic number, we write electronic configuration. Electronic configuration is nothing but the systematic arrangement of electrons in an atom is called electronic configuration. The electronic configuration of carbon is given by 1s2, 2s2 and 2p2. 1s2, 2s2. In 2p we have 3 orbitals, 2px, 2py and 2pz. First the electron enters into 2px, then the electron, normally electron after going into 2px, the next electron should also go into 2px. But Hunds says that the pairing of electrons takes place after filling all the degenerate orbitals. All the orbitals should have same energy levels, available degenerate orbitals. The electronic configuration is 6, so we can show 6 electrons and we fill 6 electrons to the half filled configuration. After filling in 2px, it goes into 2py. It won't get filled in 2px only. No doubt 2px can accommodate 2 electrons, but as per Hund's rule, the another electron will goes into 2py. Let us take about nitrogen. Nitrogen, the atomic number is 7. The electronic configuration is 1s2, 2s2, 2p3. So 1s2, 2s2, 2p3 is given by 2px, 2py and 2pz. See here, after entering into 4 electrons, we have 3 electrons are pending, and these 3 electrons, first electron will goes into 2px as per Hund's rule. Next electron will not go into 2px. It go into 2py, then it go into 2pz. This is called, these kind of orbitals are called degenerate orbitals. Orbitals having same energy orbital, same energy levels. See here, it is very clear. 2px can accommodate 2 electrons, 2py can accommodate 2 electrons and 2pz can accommodate 2 electrons. But the electrons are not going into 2px completely and 2py completely. They are filling, first they fill 2px, then they fill 2py, then they fill 2pz. Let me show you an example about oxygen. Oxygen atomic number is 8 and the electronic configuration is 1s2, 2s2, 2p4. Now you see here, this is 1s2, this is 2s2 and 2p4, 2px, 2py and 2pz. First electron will go into 2px, next electron will go into 2py, next electron goes into 2pz and one more electron is remaining. That electron will go into 2px. Then it is called a stable configuration. So pairing of the electron takes place after filling all the available degenerate orbitals. This is called Hund's rule.